Compression. Compression or data compression is used to reduce the size of one or more files. When a file is compressed, it takes up less disk space than an uncompressed version and can be transferred to other systems more quickly. Therefore, compression is often used to save disk space and reduce the time needed to transfer files over the internet. Two primary types of data compression: file compression and media compression. File compression. File compression is used to reduce the file size of one or more files. When a file or a group of files is compressed, the resulting archive often takes up 50% to 90% less disk space than the original files. File compression. The goal is to remove redundant data in each file by replacing common patterns with similar variables. For example, words in a plain text document might get replaced with number or another type of short identifier. This identifier then references the original words that are saved in a key within a compressed file. For instance, the word computer may be replaced with the number 5, which takes up much less space than the word computer. The more times the word computer is found in the text document, the more effective the compression will be. File compression works well with text files. Binary files can also be compressed by locating repeated binary patterns, and compression algorithm can significantly reduce the size of binary files such as application and disk images. Media compression. Like file compression, the goal of media compression is to reduce file size and save disk space. However, the media compression algorithms are specific to certain types of media such as image, audio, and video files. Three types of media compression. JPEG compression, which is commonly used for digital photos, incorporate a lossy compression algorithms that average nearby colors and removes color variation that are imperceivable by the human eye. GIF compression reduces the color palette of an image to 256 colors or less, which provide an efficient way to represent each color within the image. PNG compression uses a lossless compression algorithm that filters the image data and predicts pixel colors based on others nearby pixels. While each of these algorithms work different ways, they can all be used to significantly reduce the file size of an uncompressed image. Lossy compression. Lossy file compression results in lost data and quality from original version. Lossy compression is typically associated with image files such as JPEGs, but can also be used for audio files like MP3s and AAC files. The lossiness of an image file may show up as jagged edges or pixelated areas in audio files. The lossiness may produce watery sound or reduce the dynamic range of the audio. Lossy compression removes data from the original file. The resulting file often takes up much less disk space than the original file. For example, a JPEG image may reduce an image file size by more than 80%. Little noticeable effects. Similarly, a compressed MP3 file may be one-tenth the size of the original audio file and may sound almost identical. Lossless compression. Lossless compression basically rewrites data of the original file in more efficient way. However, because no quality is lost, the resulting files are typically much larger than image and audio files compressed with lossy compression. For example, a file compressed using lossy compression may be one-tenth of the size of the original, while lossless compression is unlikely to produce a file smaller than half of the original size.
Good day, everyone. I'm here to report about archiving. What is archiving? Archiving is the process of combining multiple files and directories. It is also the process of combining multiple files into a single package called an archive. This archive can then be easily distributed to another machine, backed up as in backed up in a repository somewhere, or simply kept on your own machine as a way to organize and clean up your file system. And archiving also means that you take 10 files and combine them into one file with no difference in size. So if you start with 10 and 100 kilobyte files and archive them, the resulting single file is 1000 kilobyte. On the other hand, if you compress those 10 files, you might you might find that the resulting files range from only a few kilobytes to close to the original size of 100 kilobyte, depending on the depending on upon the original type. And also, it can be thought like putting some different files into one box. So if you have 5 files, each of a size of 10 kilobyte, archiving those will give you 5 times 5 equals to 50 kilobytes. So here's the most common programs for archiving files and directories. So first is tar. So tar is a Unix command representative tape archive. So it is used to combine or store multiple files. Next is zip. So zip is a common file format that's used to compress one or more files together into a single location, and it reduces the file size and makes it easier to transport or store. So next is, what is the purpose of archiving? So it improves compliance, saves time, and increases security. Document archiving is securely storing information, both digital and paper format, that you no longer use regularly. It's important because it stops you losing data. And archiving is used to collect multiple data files together into a single file for easier portability and storage, or simply to compress files to use less storage. So here are some archive storage options. So first is tape. Tape is an effective data storage archival format because of its low cost. However, the time it takes to access data stored on tape is slower than the other storage options. For that reason, it is most often used as a long-term archival location where data is unlikely to be accessed. So next is hard disk drives. It can be used as archive storage. However, power and cooling of hard disk storage makes this option costly. Next is cloud. Cloud is a favorable archival option because it can easily scale and removes the cost of hardware, power, and cooling. However, for large data centers with continuously growing archives, like ongoing cost of cloud storage may start to add up. Some major cloud providers offer cloud archiving platforms that offer slower performances for a lower cost. Last is object. Object storage is an effective archival storage option because it has the ability to store large amounts of metadata, which is essential to easily access data. And object storage is also low cost and can store large amount of data.
Good day, everyone. I am Trisha May Bidal Perto, so I will report about archiving and compression. The distinctions are sometimes blurred in casual conversation. There is a significant difference between archiving files and compressing them. So, archiving is basically when you coalesce multiple files together, but you may also compress them at the same time. Compression, we're reducing the amount of data that is stored in the particular file so that either it will move more quickly across our communication channel or take up less space in our storage media. So these are the archive and compression formats. Zip, gzip, bzip2, and tar. So gzip was created as an open source replacement for compressed and older Unix program. It can be found on almost every Unix-based system on the planet, including Linux and Mac OS X, but it is much less common on Windows. So if mag-send kag files sa Unix-based machine user, gzip is a good option. bzip2 command is a newcomer on the scene, designed to replace gzip. So bzip2 produces smaller file at the expense of speed. However, computers are now fast that most users won't notice much of a difference in times it takes gzip or bzip to compress a group of files. So compression is focus of zip, gzip, and bzip2, although zip also archives. So the tar command does only one thing, which is archive, and has done so for a long time. It is almost entirely found on Unix-based machine. You'll definitely come across tar file, also known as tarballs. So if you download source code, but almost every Linux user can expect to come across a tarball at some point. Zip archives and compresses files, making it ideal for sending multiple files as email attachments, backing up, and saving disk space. So it is simple to use. So assume you want to send a TIFF file to someone via email because TIFF images are uncompressed. They can be quite large. By zipping, you should be able to make the email attachment a little smaller.